Hello students, for class 12, in this video I am going to discuss on continuity and differentiability. First, continuity. Now, continuity of a real function at a point. What do we mean by this? A function f of x is said to be continuous at x is equal to a if limit of the function when x tends to a is equal to value of the function at the point x is equal to a. What does it mean? It means if f of x is continuous, if f of x is a continuous function at x is equal to a, then limit x tends to a minus f of x. Now a minus, this does not mean negative a. This is called left hand limit. You already know about limit, left hand limit, that is when x approaches to a from the left hand side. So limit x tends to a minus f of x, that is left hand limit of the function, is equal to limit x tends to a plus f of x, that is x tends to a plus from the right hand side, that is x approaches to a from right side, is equal to value of the function at that point. Then it is said that the function is continuous at the point x is equal to a. Simply, continuity of a function means we should have the basic idea. Function, it should have its graph. Now if we are able to draw the graph without lifting our pen or chalk or pencil, continuously if we are able to draw the graph, then it is called the continuity of the function. It is said that the function is continuous. Now there are some remarks regarding this, what we have discussed. A function f of x is discontinuous at x is equal to a. There is for what reasons a function can be discontinuous. Point 1. If it is x tends to a minus f of x, limit of x tends to a minus f of x, that is left hand limit of the function, and limit x tends to a plus f of x, that is right hand limit of the function, exist, but they are not equal. There is both the limit exist, left hand limit exist, right hand limit exist, but the limiting values are not equal. Then it is said that the function is discontinuous at x is equal to a. That is, we can represent this as limit x tends to a minus f of x is not equal to limit x tends to a plus f of x. Now the second reason, limit x tends to a minus f of x, that is left hand limit of the function, is equal to the right hand limit of the function, that is limit x tends to a plus f of x. These two values exist and equal, but none of the limiting value is equal to the value of the function at the point x is equal to a. In this case also, the function is not continuous, that is discontinuous at x is equal to a. Now third condition, f of a is not defined. There is when we are going to find the value of the function at the point x is equal to a, it is undefined. Fourth, at least one of the limit does not exist. There is either left hand limit, there is limit x tends to a minus f of x, or limit x tends to a plus f of x does not exist. So these are the four cases for which a function is not continuous, that is, the function is discontinuous. Now, kinds of continuity. Let f of x be a function and a be any real number. Number one, discontinuity of first kind. That is, if limit x tends to a minus f of x is not equal to limit x tends to a plus f of x, then it is said that the function is discontinuous. That is, discontinuity of first kind or jump discontinuity. This is called jump discontinuity. Now, for jump discontinuity, its pictorial representation is, this is x-axis, origin, this is y-axis. Now, left hand limit, that is limit x tends to a minus f of x, its graph is like this. And limit x tends to a plus f of x, say its graph is like this. Then we see that left hand limit is not equal to right hand limit. There is a jump, that is a gap. That is why this is called jump continuity. This is actually, that is, first discontinuity or jump discontinuity. Now, discontinuity of second kind. A function f of x is said to have a discontinuity of second kind at a point x is equal to a if the limits of the function on the left hand as well as right hand do not exist at x is equal to a. That is, neither limit x tends to a minus f of x nor limit x tends to a plus f of x exist. There is neither left hand limit nor right hand limit exist at the point x is equal to a. Now, pictorially, we may represent the second type of discontinuity as, this is x-axis, this is y-axis, and this is the origin. Now, this is the left hand limiting function. That is, this represents limit x tends to a minus f of x and limit f of x, limit of x tends to a plus. Now what happens, so what we see, that is, you see here this circle remains blank. What does it mean? That is, their value are not equal. That is, limiting values are not equal to f of a. So this is also one kind of discontinuity. Now, third type of discontinuity. This is called removal discontinuity. This is called removal discontinuity. A function f of x is said to have a removable discontinuity at a point x is equal to a if limit extends to a minus, that is left hand limit of the function f of x is equal to limit extends to a plus f of x, but the value is not equal to f of a. Then this kind of continuity is called the removable discontinuity. This kind of continuity is called the removable discontinuity. Fourth type of discontinuity. A function f of x is said to have a mixed discontinuity at a point x is equal to a if one of the limits, that is the limit extends to a minus f of x or limit extends to a plus f of x, that is either left hand limit or right hand limit exist and the other does not. That is, of the two limits, left hand limit and right hand limit, if left hand limit exists, right hand limit does not. If right hand limit exists, left hand limit does not. Then this is the fourth kind of discontinuity. This is called mixed discontinuity. Continuity from left hand and right hand we have to explain. A function f of x is said to be continuous from left at x is equal to a if limit extends to a minus f of x is equal to f of a. And right hand means a function f of x is said to be continuous from right hand, that is from right, at x is equal to a if limit x tends to a plus f of x is equal to f of a. Now from 1 and 2 it follows that if a function is continuous at x is equal to a, then it is continuous from both, that is from the left and from the right. Now, algebra of continuous function. Theorem. Let f and g are two real functions which are continuous at x is equal to a. That is, the function f is continuous at x is equal to a and the function g is also continuous at x is equal to a, where f and g are two real functions. Then at x is equal to a, f plus g is continuous, f minus g is continuous, cf is continuous, that is c into f, that is if the function is multiplied by any scalar or any number, real number, then also the function is continuous at x is equal to a. Then f of g into f of function, that is product of f and g. Product of f and g is also continuous. Then 1 by f is continuous provided f of a not equal to 0 and f by g is continuous provided g of a not equal to 0. Because here in the fifth, 1 by f is continuous provided f of a not equal to 0. If f of a is equal to 0, it becomes undefined. Similarly, in case of sixth, if g of a is equal to 0, then f by g becomes undefined. Now, continuity in an open interval. Continuity in an open interval. A function f of x defined in an open interval a comma b is said to be continuous in the open interval a comma b if it is continuous at every point of open interval a comma b. So the function f of x is continuous in the open interval a comma b. In the open interval a and b, in between a and b, there are so many points. If the function is continuous at every point, then it is said that the function is continuous in the open interval a comma b. Open interval means it is not taking the values a and b. Now continuity in a closed interval. A function f of x is said to be continuous in the closed interval a comma b if number 1 f is continuous on open interval a comma b. Number 2, limit extends to a f of x is equal to f of a is equal to finite quantity, that is it exists and it has some finite quantity. Similarly, limit extends to a minus, that is left hand limit of the function, is equal to f of a is equal to finite quantity, that is it also has a finite value. Now here is a list for which without proof we can mention that it is a continuous function. We have to keep in mind, here I have listed 15 functions are included here for which to mention them as a continuous function no proof is required. Number 1, a constant function is everywhere continuous. Second, the identity function is everywhere continuous. A polynomial function is continuous everywhere. Fourth, every rational function is continuous at every point in its domain. Fifth, let f and g be two real functions such that f of g is defined. If g is continuous at x is equal to a and f is continuous at that point y is equal to g of a, that is the function g is continuous at x is equal to a and function f is continuous at g of a, then f of g is continuous at the point x is equal to a. Sixth, the composition of two continuous functions is a continuous function. Seventh, if f is a continuous in its domain, then modulus f is also continuous in its domain. The modulus function is everywhere continuous function. Modulus function is always a continuous function. The exponential function a to the power x, where a greater than 0 is everywhere continuous. The exponential function e to the power x is everywhere continuous. The logarithmic function is continuous. The sine function is everywhere continuous. The cosine function is everywhere continuous. The tangent function is continuous in its domain because it has a chance to become discontinuous, because tan of x means sin x by cos x. So whenever cos x becomes 0, it becomes undefined. That is why tangent function is continuous in its domain. The function sin inverse x is continuous in its domain. Now continuity. Again, I am giving you the basic idea of continuity. A function is said to be continuous if we can draw the graph of a function without raising our pen. Like this, for this one, we can draw the graph of the function y is equal to f of x without raising our pen. So this is a continuous function. Or another definition, function f will be a continuous function at x is equal to a if there is no break in the graph of the function at the point a comma f of a comma f of a means y is equal to f of x. For x is equal to a, y is equal to a. For x is equal to a, y is equal to f of a. That is, the point is x comma y means a comma f of a. So that is, the function is, there is no break while sketching the graph of the function y is equal to f of x at the point a comma f of a. Now there are three graphs I have drawn. Figure 1 shows the function has no break, so it is continuous at x is equal to a. Now figure 2 shows that f of x exists, but it has a break at x is equal to a, because you see that this remains unfilled, the circle is unfilled. Means for x is equal to a, the function cannot take any value. Hence it is discontinuous at x is equal to a. That is, the limit x tends to a, f of x exists, but it has a break at x is equal to, a, and hence it is discontinuous at x is equal to a. Now the third graph, for the third graph, this graph, for this graph, graph 3, for the graph 3, the graph 3 shows that limit f of x, this is the graph of the function f of x, does not exist, and f of x is also discontinuous at x is equal to a. Limit f of x extends to a, it does not exist, because these two values are different. That is, left hand limit is not equal to right hand limit, hence it is not continuous at x is equal to a. Thus we have learnt the continuity of a function, different types of continuity, left hand continuity, right hand continuity, algebra of continuity, continuity in open interval, continuity in closed interval, and there is a list of 15 functions for which without any proof we can write that the functions are continuous, which the student must have to keep in mind those 15 functions. Okay.